Hello children, welcome to maths class. In this video we are going to start a very interesting topic, that is quadrilateral of your syllabus, that is chapter 8. And we know that quadrilateral is a closed polygon, or we can say made of 4 sides. But the different type of quadrilaterals we know that start with a square, rhombus, parallelogram, rectangle, trapezium, kite. Mainly we are studying about these 6 quadrilateral, but in this chapter we will know more about parallelograms. So, we will start this topic with properties of a parallelogram. If we see a parallelogram, what comes to our mind when we hear the word parallelogram? The thing come to our mind is a quadrilateral with opposite side equal. A very common property of parallelogram we know, that is true also. A quadrilateral with opposite sides equal, both of pair of opposite sides will be equal. It is a parallelogram, but does it have only that property or it has something more? Surely it has more properties. So, we will first study about the properties of this parallelogram, we will know all that property, then we will go in exercise for solving whichever geometrical sums are there. So, let us start. The first property, what you said, that the opposite pair of opposite sides of a parallelogram are equal. In a parallelogram opposite sides are equal. So, that we all know. In a parallelogram, the opposite sides are equal. We are just now studying on the blackboard. We find that the opposite sides of blackboard are equal. We look at our notebook, textbook, so many things are there around us, even most of our rooms shape, we will find that opposite sides are equal. We look at the window door, we find that opposite sides are equal. That means, these all the shapes are having parallelogram shape. Then you may notice that the blackboard corner at each vertex, the two lines are meeting each other. That means, it makes a 90-degree angle. Surely we call it a parallelogram with one angle 90 degree is a rectangle. I hope you understood what I wanted to tell. If we look at the two walls of our room, they meet each other, they make perpendicular line. That means, that such parallelogram which has one angle 90 degree will be a rectangle. So, this also is a property of one parallelogram. So, we can say that rectangle is a parallelogram, but parallelogram is not a rectangle. Keep that in mind. A parallelogram is a rectangle, yes. A rectangle is a parallelogram. It is right, but parallelogram is not a rectangle. Like this, if we talk about a square, in a square, if we hear the word square, what comes to our mind? That all 4 sides are equal, but opposite sides are also equal in a square. That means, a square also a parallelogram. A parallelogram is not a square, but a square is a parallelogram. If we look at the rhombus, if we look at rectangle, so rectangle may be a square, may be a parallelogram itself is a parallelogram. So, these things we will keep in mind. Then another one, we will see another property of parallelogram. The diagonals of a parallelogram divides it into 2 congruent triangles. Let us see another property. First one you have understood. The diagonals, we will study now about this property. The diagonal of a parallelogram divides it into 2 congruent triangles. So, let us see now the second property. If we let us see, this is a parallelogram. This is a parallelogram, and what we talked just now in this property, the diagonal, we are not talking about two diagonals, the diagonal, any one diagonal. This is the diagonal of this parallelogram. Then what will happen? If this was parallelogram, opposite sides will be equal, and the diagonal we have drawn, the triangle are there now, how many? 2. These two triangle will be congruent. Congruency chapter you have studied that triangles will be exactly equal. Do you agree? If not, we can prove it. So, let us see, sometime we may be that this is how equal, how these two triangle will be equal. If that such questions come in our mind, we can go for its proof. So, let us see the short proof only, it is not so big, how simply saying or some reality is in that. So, after drawing this diagonal in this parallelogram, we find there are two triangles, and then we will see, do we get some corresponding parts of these two triangle equal? Is it possible to prove that the triangles are congruent? If we give the proof, that means it is acceptable. After giving proof, after getting the proof, we will surely accept that. So, let us see, we are going to prove this. The diagonal of a parallelogram divides it into two congruent triangles. So, let ABCD be a parallelogram. A parallelogram, we just write in short symbol of parallel and GM, parallelogram. And BD is what? BD be its diagonal. Its diagonal. So, this is here in this figure. Now, what we have to prove? We have to prove the two triangles are congruent. To prove which are the two triangles? Read the name of that two triangles. You can start from any vertex ABD, or you can say BAD or DAB. So, let us see ABD triangle. In triangle, to prove triangle ABD will be congruent to triangle, another triangle what we see, BCD, DCB, CBD, whatever name we give. So, let us see BCD. These two triangle we have to prove. Then question comes, how we will prove? What you will say in proof so that all will accept it, or we all will accept it, what we shall give in proof? We have to work in these two triangle. We will work in triangle ABD and triangle BCD. What we are searching for? We are looking for or searching for the corresponding parts of this triangle. If we prove some three corresponding parts, maybe all three sides, maybe two sides, one angle, you know that ASA congruence condition, SAS congruence condition, or SSS congruence condition. So, what we see, first of all, in this triangle we see AB and another triangle CD, these two sides are equal. Why? Because they are the opposite side of parallelogram, figure is the parallelogram. So, these two sides will be surely equal. One side is in this triangle and this side is in another triangle. So, this corresponding side of both triangle are equal. We will just write, look at the figure, find that corresponding sides or angles equal and write. This is given. Why? Because we know parallelogram opposite sides are equal, the first property you are seeing here also, and we know it, no need to see it anywhere. We know that parallelogram opposite sides are equal. Okay, something more you try to see. I have seen the side is here and another side is this. So, AD is in this triangle and BC is in this triangle, these two sides are equal. We will write that they are also equal, AD is equal to BC. Reason is same, it is given because the it is a parallelogram, opposite sides are equal. Then one more, something do you find? Yes, I have found this BD is in this triangle also, in that triangle also. So, same side is common in both triangles, surely that will be equal. So, BD is equal to BD, same something will be equal to itself, and this is what we are here ready to give proof. In any triangle, if three sides of one triangle is equal to the corresponding three sides of another triangle, that means triangles are equal. Triangles will be equal on with angles, with sides. We have found here, we have got here three sides of corresponding three corresponding side of triangles are equal. So, we are able to say the triangle ABD we use the name, is congruent to triangle BCD. What is that congruence condition? By side congruence condition. And really this is true. When a diagonal is drawn in a parallelogram, it divides the parallelogram into two congruent triangles. I hope you have understood. Let us see the another property. So, another property of parallelogram about the diagonals of a parallelogram bisect each other. We need to remember this, all the properties. The diagonals of a parallelogram bisect each other. So, we will understand this in figure. Let us see if this is a parallelogram, the diagonal it has. We are talking about diagonals, not diagonal. Always listen to the word, it will have different meaning. When we say the diagonal, that means we are talking about one diagonal. Here we are talking about the diagonals, that means a quadrilateral can have at most two diagonal only. We are talking about both diagonal. So, if ABCD is a parallelogram and then we have joined the diagonals AC and BD, they are intersecting at O. Then what will happen? You know what you understood with this statement? The diagonals of parallelogram bisect each other. That means we don't say that the both diagonal will be equal. We are talking about wherever they are cutting, they are intersecting each other. From there they will be half. That is the meaning of bisecting. So, OA will be equal to OC and BO will be equal to OD. This is the meaning. We need to remember it. When we start exercise, we all will be using these properties. Hope you have understood this property. Then next is that if the diagonal of a quadrilateral bisect each other, reverse. If any quadrilateral it is, diagonals are bisecting each other, it will be the parallelogram. Or if parallelogram are diagonals, they are intersecting each other. So, it will be half. I hope you have understood this property. Next video, we will start the solution of exercise 8.1. So, till then you need to understand this property and keep in your mind, so that it will be very helpful when we are doing the solution. See you in next video.